given a cubic, which has been sketched, told it passes through the origin. It has a local maximum at 2, 8 and a local minimum at 6, 0. We're then asked to write down the set of values for which f dash x is less than 0. That's another way of saying dy by dx is less than 0, or where the gradient is negative or the function is decreasing. And it's going to be for these values here. So at x equals 2, the gradient 0, and at x equals 6, but it's going to be between them. 2 less than x less than 6. The line with equation y equals k intersects c at only one point. Find the set of values of k. So y equals horizontal lines. This one, about y equals 4, I guess, actually intersects at 3 points. So that's not going to be included in my set of values. But if I move it up, so here, actually, this is the point where it's just hits 2 of them. If I go above it, so above y equals 8, then I'm just going to get 1 point intersection. So k could be greater than 8. Actually, if I went down instead, I could have k is less than 0. So at 0, it's going to hit 2, but then down here, it's just going to hit 1. So k greater than 8 or k less than 0. But we're asked to write it in set notation, so we just have to modify it slightly. It's the set of k such that k less than 0. I'm going with the one on the left, like the lower one to start with, but it actually doesn't matter. Close your set, and then it's the union with the set of k such that k greater than 8. That is our answer in set notation. Finally, find the equation of c. We can leave our answer in factorized form. Okay, just going to do a bit of groundwork before we... So this is like a reverse. Like I'm going to cover 2 questions where we're actually sketching the graph. Now, what about y equals x plus 1 times x minus 2 times, let's say, x? Then the roots would be minus 1. That's where it crosses the y-axis. Sorry, the x-axis. Because when this thing is 0, or 2, or 0. This is a positive cubic, so it would look like this. So in a minute, we're going to be doing the reverse. We're going to be looking at the sketch and getting back to the factorized form. What if I had y equals x plus 2 squared times x minus 3? Now I'd put a point at minus 2, but this is a double root. We'll talk about what that means in a second. And then this would be 3. So it actually is not going to intersect. It's going to go down like this. And we can see from the intercept, by the way, to get the intercept, we would just multiply the numbers. So 1 times 2 times 0 actually gives 0. Here, 2 times 2 times minus 3 would give me minus 12. So it looks like that when you have a repeated root. And that is going to help us out here because we have a repeated root. So y is going to equal x, because I've got a root of 0, and then I've got a root of 6, so it will be x minus 6 all squared. Now in this case, that's not the final answer because we've got to make sure it goes through the point 2, 8, and it doesn't at the moment. So I need to put a k in front of it, some scaling factor, because there's actually lots of possible cubics that might see that one there would also go through 0 in one place and touch twice with 6. So, it's a different cubic that has those roots, but I need to make sure it goes through 2, 8. So I put a k there. Now we can substitute it in our point. So 8, that's my value of y, is going to equal k times 2 times minus 4 squared. That's just going to be 16. So k is 8 divided by 32. It's actually going to be a quarter. That is our final answer. Y equals a quarter x minus 6 squared. The factorized part ensures we go through these in the right place, and the double root on the double x minus 6 means it's a repeated root and it doesn't cross, and the quarter ensures that it hits that 2, 8.